Okay, so this is what we're going to go through. Lists and loops, breakout, strings and loops, breakout, nested loops, breakout. There are breaks as well in between, a couple of them, and then what we'll do is we'll end with coursework Q&A, so anyone can ask more questions on that rather than let it get in the way of this stuff. And you'll also notice that we're covering over some things that we've mentioned before, but now sort of more combined. And if you look at the topics, they're the kinds of things that you're almost certainly going to need for the coursework. So they're all there. Right. Firstly, list operations. So again, I'm going to do this inside Python. So I'm going to do it inside the interpreter. I mean, you can do this in your program. Here, remember, we did this at the start, and we used occasionally to try things out in almost like an immediate mode. I type it in, and it runs there and then. Okay, but the syntax and everything else is exactly the same. So, initializing lists. So we've done this, but just as a quick recap, we can say A is equal to an empty list, not a problem. We can say A is equal to a list with some stuff in it. Also not a problem. Don't need the extra enter, that was just me making a mistake. You can get lists out of things, as you just saw with map. You can turn other things into lists. So you'll see us use this list function, which turns things into lists occasionally, and you can put anything else that's iterable in there, like this, including strings, to turn them into a list. So you'll see these things used quite a lot. Indexing and slicing. Well, let's make A equal to a much larger thing. So let's say it's to 100. Oh, this is the other use of lists. A equals list A. In Python 2, the range function returned a list, not a range object. But it's okay, we can convert it to a list. So we have 100 items in there, and just because currently they're in order and the 0 element is in position 0, I'm going to shuffle them. Okay, so input random.shuffle A, and there it is. Okay, so that's our list now. It's a shuffled list of 100 items. All right. Now, if I wanted just the first 50 items, okay, I should be able to go A. We know we can get 0. I'm not going to go back over this. That's the one in first position, then one in second position, and so on. So you can see 12, 37, 33. So that we know. And you should also remember that we can also do negative numbers to go from the end of the list and come backwards. So -1, -2, -3 are 80, 24, 29, 80, 24, 29. Come backwards in the list. So the one that I think is worth repeating a little bit in more detail is the slicing operation. Okay, so we have A. We don't just have to put one value in here. We can actually put two values separated by a colon. So if I put 0 to 100 in there, I actually get the entire thing. And that's because we go from the first item 0, up to, but not including the last one, which would be index 100. That's 1 over the end. So that's 0 to 99, if you like, inclusive. But I can change that. I can go up to the one at 50. Now, remember, it goes up to, but not including. So they don't want to tell me what the length of this is going to be. Or type it in chat and Adam will tell me what people are guessing. No one gonna have a guess?
49 apparently.
Okay.
51. Yeah, this is perfect for straw poll time. We should have made a straw poll for this bad boy.
Yes, I need to try it before.
Yeah.
I think I'm used to doing things. Let's do it right here, but maybe not with an external web service.
We've got a couple of people saying 50.
I hope everyone's saying 50 now they've seen it, because
Okay.
the answer's on screen.
I was going to say, yeah.
if you're still saying 49 or 51, so there's no wrong answers, but once I've given you the right answer, I think then the wrong answer is definitely wrong.
True, yeah.
But it's 50, and the reason is, and this is I wanted to go over this because it's 0 up to, but not including position 50. But because 0 is the first position, 0 to 49 is actually 50 numbers. It's 50 things. So that's 50 parts of the array. So it's from the 12 up to the one part way along. In fact, let's see what we get out of it. You can see it goes up to that 23. Already printed it once, 23. So you see it goes to there, and then this bit should also be 50. And the nice thing about these things is if we then do 50 onwards, so do it the other way around, we get this, and that's the other half. So 0 to 50, 50 to 100 doesn't have an overlap, right? With 23 and then 41. And if you look at the full list, it's 23 and then 41. There's that breakpoint. Okay, now sometimes you'll want the first 50 items of the list. You don't really know how long it is, and you don't really want to have to count it. Okay, so how would we do that? Well, we can go, the last 50 items or the first 50 items. We don't want to keep referring to the end point. I just realised that wasn't a good justification for what I'm about to do. So you don't have to specify both of these numbers, and if you don't specify the numbers, you get the default, which will be, for the first number, will be the start of the list, and for the last one will be the length of the list. So if I said up to 50, I get the first lot. And if I said 50 onwards, I get, in this case, the last half. But it might be that, this is actually 1,000 values. So how would I use this to get the last 50, which is where I was actually trying to head before? So I want to have a guess at how I can get the last 50 without having to find out the length of the list.
Come on, chat. I want to see some chat spam. Make the magic happen. Okay, we've got an I don't know. We've got a minus 50 colon.
Ooh.
We've got colon 100.
Give the minus 50 colon person a house point. Right?
Oh, yeah.
Yeah, because we can use negative numbers to refer to the end and count backwards, right? So that says I want the last 50 items in the list. Okay, so you can also use it the other way around. You can say I want everything except the last 50 items in the list, and take them out this way. And this is really, really handy, right? So this is the kind of stuff that makes Python a joy to use when you do this kind of, have a list of things, I have a bunch of stuff from a file, I have a load of numbers I've generated, blah, blah, blah. You always want to do these kinds of things. And rather than have to go, right, a dot from and to, or whatever the notation is in another language, you have it all there. You can use this slice notation. It's built in. It's part of all of the sequences and things that you use. Great. These things also apply on strings, so we'll see them probably again many times. Okay, so appending is the other thing that's really important. Again, we have done this, but I just want to show everyone. There's our list currently. I'm going to add 1,000 onto the end. Done. No problem. If you want to find out more about what you can do, you can use help, and you can actually look at what each of the things that you can do are. So, clear removes all the items, copy, but we don't use all of them all the time. There's no point me going through in a lecture that this is what this one does, this one does. If you go, I need to actually insert something into a particular position, you'll be able to look in the help for lists, and see all these functions and go, yeah, that'll be the one. And if it's not there, you then go and Google it, right? So let's say you wanted to, let's say you wanted to, I don't know, what would be a good thing you want to do? Delete all of a particular kind, right? You might go, that'd be useful. Have a look. Do we have a delete? We don't have a delete, right? So maybe you Google it, and then you'll find there is a way to delete stuff out of there, and it's a different kind of notation. But the help is really handy. Okay. So appending, counting. So length of A is this. That's fine. We've counted all of the values. But what if we wanted to count the number of things in a list, right? So let's say a list, we've got actually unique numbers there. What about if we went through, let's make a new list, and this list is going to contain the remainder of each of these numbers divided by 7, right? So let's try that. So I'm going to call my new list because I have no imagination. And I'm going to say for I in A, which is our original list, new list dot append I mod 7, right? So we're using append. I is going to be each one of the values in A. A is this big sequence of 101 values, and this percent sign here means find the remainder of. I think we've already discussed it, but we haven't. That's what that means. It's pretty much always that in every language. So we're adding to this new list, which starts off as empty. Okay, done. Let's have a look and see what new list contains. There we go. Now we've got a lot of repetition in these numbers. Okay, so how many of these things were perfectly divisible by 7? Right? What's the remainder of something divided by 7 if it's perfectly divisible by 7?
I almost answered without thinking about it then.
Well, we'll try to train the entire group to do that then.
That's it, yeah. What do you guys think? We've only got one answer so far, so 2.
Is it the right answer?
I mean, it is the right answer.
Okay.
It is the right answer. It's 0.
That's fine. So it's the reason we ask the questions is to try and make sure you think about it, because if you just get the answer, it sort of it doesn't stick. So trying and thinking, well, what would it be? What would it be? You know, even if you then get it wrong and get told what the correct answer is actually a useful thing to do. So let's count the number of zeros. 15. So there are 15 numbers that divided by 7 without a remainder. Okay, we can count how many had a leftover of 1, 2, 3, 4, 5, and 6. Okay, and you can see they're all 14 or 15, which makes sense because as you repeat, you know, you've got a remainder of a given number, and then you'll have, you know, that remainder plus 1 and so on until you get to another multiple, then it goes back to 0. So you can see that pattern, you know, through the list. As you go up, you can sort of see, you know, the numbers repeating quite often, same kinds of things popping out.
Is there a way to count that doesn't use the dot count method? Is there a way to iterate through it or find out the indices?
You could
anything else like that? You
could easily write a loop to do it. I mean, just like we wrote the loop before, we could do something like for I in what new list, wasn't it? New list. If I is equal to 0, and 1. We could do something like that quite easily. Yeah, we'll get those out. We could have a counter at the start again, which we'll actually look at in a bit. You know, as an accumulator, you go through and count the number of items that way. So there's a few ways you could do it. If you wanted to actually do it by finding the position, you do it like this. So range length of the list, right? So this is going to be numbers up to from 0 up to, but not including the length of the list. So it's essentially the position of each item. And then we could say if new list at position I is equal to 0, oh, sorry, these are the wrong brackets. That was a bit weird. Let's try it again. New list at position I. There we go. We get number at position 5 was 0, 7 was 0, 14 was 0, and so on. So you can iterate through it in a few different ways. But look at the amount of code I'm doing. You know, if I just want to know how many, count is brilliant. You know, it's there. If you want to do something more, like check the positions and things like that, then you've got to write your own loop. And actually, yeah, this is the kind of stuff perhaps where you know, you might use map more, you know, to apply these functions. But like I said, I'm not really going to get into using those particularly, because they're almost the kinds of things that they're great in those cases when they're useful, but it's much more useful to know the general purpose way to do things and not have, you know, this odd map that takes a lot longer to decode what's going on because people don't see it very often. Okay, so the next thing I was going to go through is actually the thing that's come up now because of this. We have two ways to iterate through lists, more really, but two common ways that we iterate through lists. The first one is that we're going to have a loop that goes for I in A. All right, so here we just do it. We'll print out the values. So that should give us 101 values. Sorry, for I in A, print I is what I actually wanted. I printed the list 100 times rather than the items. So there we go. Print out each item. That's fine. And if all you want to do is process each item, not a problem. If you need to know the position, you have to then, if you wanted to do it this way, you have to keep a counter, and then you have to add one to the counter. And that all starts to get a bit complicated and liable to have errors. It's much simpler then, I think, to do range and do the length. So now what we're doing is we're going through I will be 0, then 1, then 2. And these represent the positions in the list, not the values in the list. So in this case, if we wanted to print out the values, we wouldn't print out I, we'd print out the item at position I. And the nice thing here is that we could also then include, you know, I and the thing at position I. So it's like having a position followed by the thing at that position. Okay, that's not too bad. If we were going to be tidy about these things, and today's a good day for talking about these things because this is what we're kind of doing, we could say I and then have a colon, and then we'll put AI. So now we're switching to an F string. If you remember, you put an F at the start of the string, and then anything that goes in the curly brackets is essentially a bit of Python code, so it's referring to the values, things like that. And you might also remember that we can pad them. Right, so this first one on the left, I'm going to say is padded by 4 digits. Okay, so 4 digits of space, and the thing on the right is also going to be padded by 4 digits. Right, so let's see what that gets us. Okay, gets us this. Much tidier, much easier to see. Let's say that I wanted the thing on the left to be padded by zeros, though, not spaces. Okay, then I do this. I put a 0 in front. Actually, put in the loop first. Put a 0 in front, and then they are padded by zeros. That seems very useful for coursework. Hint. Okay, make sense? You can also use this F strings to say which way roundings go. So you might go, well, this is padded by 4, but I want it left aligned. I think that's the right way. Yeah, there we go. I can't remember whether you put it to the left or to the right, but there it is. And there you can see it's aligned them up on the left. If we had a string in there, so let's say, I don't know, what should we do? Is there a lorem ipsum generator in Python? That'd be quite useful now.
Not that I know of.
Random text. Okay.
You could import the Zen Python. Import this, isn't it?
Actually, do you know what? I'm not even. I'm going to go to that site, and then I'm not going to use lorem ipsum. I'm going to use the actual text. So let's say we've got some text. I use triple quotes because it's possibly got new lines on the end. Which I don't think it does. So that's quite nice. So we've got this string, and if I want to go through and print out each of the things in each position, then I'll first want it as a list. So I'll split it first. Get into the strings part, but we'll come back to that. I'll explain in more detail. So we've got each of these components, and then say for I in range len of s, which is a list of words. Print f string. So we're going to go for the position first, and that's going to be I, and I want that to be 4 zeros padded. Okay, so it'll always be in a size 4 space and to be padded by zeros. Then I want a colon, and then I want to have the string that we're currently looking at. So that's going to be si, so that's the current word, and I want that to be padded by let's just say 20 characters. Okay, and to show that this is happening, I'm going to put it like that. So I'll put a bar on either side so you can see where those things are. Notice, now they've defaulted to going to the left. When we did it with numbers, they're defaulted to going to the right, which is actually really sensible because generally that's what you would want, right? Text goes one way, numbers go the other, but not always. Okay, sometimes they're not really numbers. Yeah, that you want them to be, show up as if they're text. Sometimes you don't want things left aligned because you actually want to compare the right-hand sides and go down a list, whatever you want to do. So this time I'm going to do it the other way around, and I'm going to say I want these to be right aligned, and then I move over to the right-hand side. Okay. Okay. So this was iterating over, and then I wanted to go through common patterns. Right, so we've kind of seen some of these things already. You've seen me sort of print stuff out, but more likely is that I want to do things like count the number of things that have, maybe punctuation. Right, so how many full stops are in these words? Because some of them will have a full stop on the end. Right, there's one, and that'll tell us how many sentences there are. Right, so we could say, well, we can count sentences. So for that, what I would do is I would start off with something. I'll call it sentences, and it's a counter, so it's going to be 0 to start with, and I'm going to add to it. And this is this pattern that we see a lot, and I could the accumulator. It's quite a common thing. So you'd say for I in S, so I will be each of those things. I'm not going to worry about the position of them; it doesn't really matter for this. So I use the simple version for I in S. If dot in S, okay. Remember, we can use the in keyword to check if one thing is inside another. Then sentences has one added to it, so we use the shorthand that you remember, plus equals 1, which is just short for sentences equals sentences plus 1. And we don't need an else, we don't need anything else in there, so we'll go through, and then let's see what's in sent. That didn't work. Right, hold on. Oh, right, sorry. Like I'm going to talk and code at the same time. It's not if there's a dot in S. S is the list. It's if there's a dot in the current item in the list that we want. I want sentences, and then let's see what's in sentences. And there are 4. So does that work? Let's have a look. Text. There's the first one. The second one. Third one. And fourth one. Yeah. So we've managed to count the sentences. And that's a fairly common pattern. You'll see this. Parameters, we can actually take this and make it better, right? So we've got a thing that sort of counts sentences, but like at the moment, it's only going to count on a string called S, and you'd have to copy and paste that code all over the place, right? So why don't we instead make a thing that will take a list of words and count to see how many sentences are in by checking if any of those words end in a full stop, right? So we might say def count sentences, not catch C, count sentences, and you expect to be given a list of words. Okay. The reason it's a list of words and not a string is because we're going to come on to strings in a bit, so I'm sticking with that for now. And then we would have that code that we had before. So for I in words, let's have a counter first. Count equals 0. I called it sentences before. Here I'm calling it count. Both are perfectly valid things. The reason I'm using count in here is because it's a counter, and I'm counting things. Before, it was still a counter, but it was in the global namespace. So it wasn't inside a function, which meant really I should have something that makes sense. In this function, this only has one purpose, and it is to count, right? So it's to count those sentences. So I've called it count. To me, that makes sense. As long as you have something that is understandable, that is fine. You don't have to try and follow my logic on those namings. But a sensible name, that people can understand. So for I in words, so go through each of the items in there. If there is a dot in that word, we add 1 to count, and then once we've finished the loop, so the indentation is all now back out, we're going to return count. Okay, and you can see the indentation, just as a recap, anything that's inside this function will be indented by 4 spaces, which these are, and anything that's inside this loop is indented. The Python interpreter is showing these as slightly larger than it should, but I don't know why. They're just indented the same length as this. Anything inside the if statement is indented, and this return count is not in the loop and it's not in the if statement. It's not controlled by either of those, so it doesn't happen over and over. It happens once at the end, and then we're back out of the function. So count sentences on S gives us 4. This means we can use this to count any type of any size list of words to see how many sentences that represents. Okay. And then the last sort of thing that I'll do is the filter, which is another sort of common thing. So we've seen the accumulator. We've seen it using a list to pass a sequence of things into a function. That's also very common. You know, here's a bunch of stuff to process. Go and process it, or go and give me some aggregate data, whatever. The other one is to filter things. So you return something that is maybe shorter than this, has fewer things in because it's taken some of them out. Quite good in sanitization, which bad word filter. So what we're going to do is we're going to define a function. We'll call it filter bad words, and it's going to take 2 things. We're going to have the words that you're going to pass in. So this is going to be like this S string that we've been using, where you've got a sequence of words, each one as a separate item, and we'll ask for a list of bad words. So we're essentially saying, here's a list of words and a list of bad words. I want the list of words that doesn't contain the bad words. Okay. So how are we going to do this? Well, we're going to go through each word, and then we're going to check to see if it's in the bad words list. Right, nice and simple. That means we're going to need an accumulator, because we're going to want to keep a new list that contains the stuff. We don't want to modify the list we've given. We want to produce a new list. So we'll call it clean. That makes sense to me. It's an empty list. Then for each word, let's just call it word this time. For word in words, if word in bad words, what do we do? Well, actually, we don't really do anything. So let's just change this and say if it's not in there. So I know this again, because I see a lot of people try and write this. If word not in bad words, that doesn't make sense, right? In works. This the opposite of that, right? So it inverts the Boolean that comes out of this operation. So if word is in bad words, it's true, and the not makes it false. If word wasn't in there, then the in gives you a false, and the not makes it true. Okay. So if it's not in the bad words list, then we can add it to the clean list. Okay, so clean.append word. Okay, and at the end, we don't need to do anything else. If it's a bad word, we just ignore it and return clean. And there we have our function, right? So again, accumulator. Again, we're passing in parameters, but now we're filtering. Sometimes you won't do all of those things, but here we're using them all at once. And what I'm going to do is I'm going to try it out by saying filter bad words S, but I really don't like the word and. Okay, so let's put that in. And I also don't like the word in. Bad word. So we're going to take those ones out. And hopefully, the reader will be distracted by the reader of a page when looking at it out. What is using Ipsum is that it is. Although, where's a good example? Still in their infancy. Let's have a look at that. So, some sites still their infancy. Good, that works, right? So let's have a look. Is there a that I can have a look somewhere near the start?
You could use list.count to find it, James.
I could. That's a good point. Let me just see if we can find one to look at really quickly and easily. I looked and there was I'm sure there was, or maybe there wasn't. There's 3 of them. So look in the output.
Second to top line on the left.
Thank you, whoever that was.
No worries.
Okay, so in our output, filter words. Oh, I didn't filter that. I filtered and. I'm so sorry. This is just failing on words. And web pages. There we go. So patches and a search for, and we just get text as search for. So it works. Okay. So we have a bunch of list operations we talked about, 2 different ways that we generally go through, 3 of the common things that we do with lists a lot, the kind of things that we use them for. And what I want you to do is firstly to think about how those patterns solved a lot of the problems that we've seen. You've actually seen every time we've done little examples with these, you've seen almost these 3 things come back over and over again. Very useful in the coursework. Okay, so if you look at the things that you're asked to do, having loops of things that generate numbers, and padding and things like that, very handy. Having things that perhaps have to make a new list out of another list. Well, that's sort of what the bad word filter just did. So you have one list of things and then you manipulate that list. In this case, we're filtering a take list of out. It's also easy to see how you can have that and end up with more stuff at the end. If, for example, just off the top of my head, you took those things and instead of just removing a word, you put that word with some variations on it, append those to the output list. That's another good use of the accumulator, and so on. Okay, so in the breakout, I've got two tasks. One of them is very, very simple, shouldn't take you hardly any time at all. The second one is going to take a little bit more thought, but not too much. We'll say for 20 minutes, this is what we're going to do. The first one is to write a function to return the mean value from a given list. So you want to find out what the sum of all of the items is, and then return that divided by the length of the list. Okay, just a quick thing. If I have a list of numbers, I can do sum A and len A to find the sum and the length. So don't be trying to write code to count everything you don't need to. Second one, write a function that checks for duplicates in a given list of strings and returns true if it contains any, false otherwise. Okay, so how are we going to test this one out? Well, first of all, cat and cat with different capitalizations are going to be the same. My recommendation to do this is that you go through the list and create another list to start with. Go through the list you're given, and for each item, you check to see if it already exists in the list of words that you've kept. If it doesn't, you add it to that list. Okay, if it does exist in the list, you just return true, and at the end of the function, you return false. Okay, so it's a very simple algorithm, but does require a couple of steps. Okay, the link to this page with these descriptions is on the thing that's not Moodle, Aula, sorry, is on Aula, so you can no, it's not, it's on Teams. Oh my goodness, so many platforms. Right, let me just reset. It is on Teams in the chat there, and I'm going to paste it. No, I'm not going to paste it again because that's this. That's not what I wanted. That's what I want. There we go. Okay. So, does everyone want to dash into their breakout rooms, the usual places? I'm in one, and I'm not even going to try to remember where Adam's. I think I keep swapping it around.
No, you don't. You don't. What's the one that comes straight to your mind?
2.
Yeah, there we go. I'm in 2.
Okay. Brilliant.
And that's the one you always say if it helps. So
Okay.
you're all right.
So that means I'm in 3.
So you're in 3. But I always think like, no, I think I said 2 before, so it's 3. And I think, no, wait, because I think that was what I said last week, so it must be 2. Right. So we'll go and do that. We'll take 20 minutes. Let me just see what the actual time is. Come on, 12:57. We'll take 20 minutes. Let's say it's 55. So we'll come back at 15:15. Yeah.
Sounds good.
Okay,
What are we doing again? Can you just stick the tasks back up? Because I need to make a note. Sorry.
There's a link in the Teams thing. Just paste it as well, Dan. There's it gone. Let me paste it again.
Oh, got it. Thank you.
Okay, and then it's the first breakout on there, which is so write a function to return the mean values from a list, and write a function that checks for duplicates but ignores case. So a list of words, and then it'll return true if there are any duplicates and false if they're not. If you find that really easy, so anyone that's like already had the programming experience, there is a challenge task as well now, which is to write a function that can double or almost double the length of a list of numbers by simple linear interpolation. The original values will have the average value of each pair inserted between them. What that means is this list 1, 2, 3 becomes 1, 1.5, 2, 2.53. Okay, so if these take you hardly any time at all, or you just want a challenge for later, try this one. Okay, I promise you it's not super difficult, but it's definitely a step above the stuff that we're doing so far. Okay, right, I'll see you all back here at 1:15. Right.
Yeah.
I'm going to quickly go through a solution to these things. So I've got them both here. The first thing I did was I copied the stuff into my Python and put it in comments so I could remember what it was I was supposed to be doing. And I've now got two functions ready to fill in, and I'll do them one at a time. And I've made some notes about what should be in them, right? So I'm going to do this one first. So mean value. Well, remember that we can count the number of items by asking for the length, right? So len values. And I also told you that we can find the total using sum. Then we divide one by the other. Okay. Now we should test this out. So we can put some code here. I'm going to do it with the if name is equal to main. You could just write the code in there. But yeah, if these are functions that we might want to import somewhere, I know this is a little exercise, but we playing along, then we put this stuff in name equals main like this because it doesn't execute when this module gets imported, right? So you won't really, you won't really experience those problems just yet, but you'll see me do this because it's habit and good practice to do it. So we'll get into this a little bit later in the course. All right. Let's test out mean value. So say numbers is equal to 2, 4, and 6. That's nice and easy to work with because we've got numbers with one definitely in the middle, so it should actually be 4. And then we can say print f string mean of numbers is. And then we'll put the value in. Now we could just do mean value numbers in here. That'd be the easiest. We could have stored it in a variable or whatever else, but I'm going to do it this way. And then I've just quit Emacs. So I thought I was in the terminal for some reason. I just saved and went Control X, Control C. Oh dear. Let's try that again. There we go. So let's try running it. I'm just going to run it inside here, but you can go and save the file and output and the rest of it. And we get the mean of 2, 4, 6 is 4. That makes sense. Let's try it with some of the values. So let's say, well, let's try just 2 and 6. That should give us the same output. Yes, it is. The mean of 2 and 6 is 4. Let's try 6.5. That should make it go up by a quarter. It does. We'll try taking this down by half, which should bring the average down by a quarter. So back down to, that works. And let's just try put in a bigger difference. 1.5 to 6.5 is 14. So let's look, 26.5 minus 1.5 and divide the difference by 2, or we can add them together and divide by 2. Either of those should work. So let's say 28 divided by 2 is 14. 26.5 bias list should give us that plus, yeah, that all works. Right, so quite simple. Test out quite easily. Done. Right. Now let's have a look at how we would make this one work. Right. So I've given you a bit of an algorithm. So I said that the first thing we would do is we would make an empty list of words, call it something other than words because that's what's being passed in. I will call it scene. So scene is an empty list. Okay. Things. There we go. Iterate over the words, so we're going to have a for loop. So let's put that in. For, well, let's say word in words, right? That seems nice and easy to understand. And then what we need to do is for each word, check if it exists capitalized in the scene list. Okay, right. Missed a way out there, but we'll come back to that in a second. For word in words, if word dot upper true. Okay, so if we've already seen it, now we need to make sure that if we haven't seen it, it goes in there. So after this, we don't need to check if we haven't seen it, put it in, because we're going to put it in anyway if we get to this point. If it's seen already, we'll have already returned, so we don't need to worry about duplicating anything. So scene dot append, and then word dot upper. That one. Let's take these comments out because actually I was going to leave them in because we're just filling in this, but actually it seems like it makes it less readable if we have that many. And then after the loop, return false. Because if we've gone through all of this list and we never found a word that we'd seen before, then return false. So let's think about this. If words is the cat sat on the mat, okay, then we go through, word is firstly the, and it says, right, if word.upper, so that's the uppercase version, THE in capitals, is in scene, well, it won't because it's empty, return true. So we're not going to do that. But then we append the uppercase version. So this will then have, THE added to it, okay, be part of that list. And it's the cat sat on the mat. So now we go to cat. So cat uppercase, is that in there? No. And it keeps doing this and adding the word each time until we get to the bit where it says the mat, right? So we're on the, and it goes, right, the is in there, we return true. If we didn't have a duplicate, so let's say it's just the cat sat, then we would go through this loop and we would never hit this return true, which means we would continue until we'd seen every word and then we'd return false. Okay, so nice and simple. So we'll try this out with some examples. Example 1 is going to be equal to maths, which we've just done, and we're going to split on space because that's what we said we were going to do. We're going to take in a sequence. I could have written a list that had the cat sat, but this is just easier. And example 2, say, split that. Okay, so we can then say print I'm going to be very lazy and just put true or false on the end. Check duplicates. So we should have one that has duplicates and one that doesn't. So this is going to be a test to make sure that works. Didn't make left strings. Okay. See what we get. There you go. So, does the cat sat on the mat contain duplicates? True. Does Mimsy work that Borrowgross contain duplicates? False. Okay, so there's our two answers to those things.